Hi everyone. Today I'll be continuing on with what we were talking about in the last video, which was properties of acids and bases. So I did cut off right at the end of that table that kind of compared acids and bases, how what their pH is, how reactive they are, what they taste like, and things like that. But now we're going to go into, what makes something a strong acid versus a weak acid. And really the strength of an acid or a base depends on how they ionize in water. And ionization just means how they break up into their individual ions. Okay, so, a lot of things have the cation and the anion, the positive charge and the negative charge. So when they ionize, they are separating into their individual ions. Now, if you're a strong acid, you are going to completely ionize. So they're very good at separating. And because they separate, their pH is going to be close to 1, which is very low. And that's due to them being strong electrolytes. So remember, back to the Arrhenius definition was that acids will release hydrogen ions in a solution. So if it's a strong acid, it's obviously going to release a lot of these ions. So essentially, the more hydrogen ions you have, the stronger the acid is. Okay, so for example, here we have hydrochloric acid breaks up into hydrogen ion and chlorine. So this is completely ionized. This is the positive and this is the negative. Okay, so if you were to think about this, how could you draw 5 strong acid molecules if they're dissolved in water? Okay, well, if this is one molecule, remember, we are ionizing completely. So really, you're going to have like a small molecule, and then they just like kind of separate, kind of like that. So basically what we're trying to show you here is that they will completely ionize or separate. Okay, now with weak acids, they only partially ionize. And because of that, because they're not releasing as many hydrogen ions in solution, they're going to be weaker acids. So their pH is going to be closer to neutral, which is 7. Okay, so in the grand scheme of things, 1 is very low. It's very low pH. It's a very strong acid. But as you get closer to 7, your pH is maybe 5 or 6. That's indicative of a weak acid. Okay, so kind of to compare here, if this is your molecule, since they only partially ionize, some of them will stick together and some of them will separate, but then some of them will stick together and some of them will separate. Okay, so here I'm just showing you that they ionize completely, and here they only partially ionize. So this all leads to the pH scale. And the pH scale helps us measure how acidic or basic a substance is. And the scale ranges from 0 to 14. 0 being the most acidic and 14 being the most basic. Right in the middle is 7, which is a neutral pH. Okay, so again, the closer you are to 0, this is a strong acid. And then the closer you are to neutral, this is going to be a weak acid. Okay, similarly with bases, if you have a weak acid, that's going to be closer to 7 as well. And then the stronger the stronger bases will be closer to 14. Okay, the and just a kind of chemical vocab, pH stands for power of hydrogen. Okay, and what I mean by power is exponent. So this is all on an exponential scale, and it's actually based on a logarithmic scale. Now, we're not going to get too much into the technicalities of the log, but I do want you guys to understand that we are able to determine the pH based on the concentration of the hydrogen versus the concentration of the hydroxide. Okay, so in looking here, the hydrogen concentration is what determines the pH. Okay, so where you see these brackets means concentration. Okay, so if you have hydrogen in the brackets, this is what's going to determine the pH. Okay, whereas the concentration of the hydroxide is going to determine the pOH. Okay, now if you add the pH plus the pOH, it equals 14. Okay, and again, this is all based on this log scale. Okay, so let's say I have the hydrogen concentration. All right, the concentration, if you look at the exponent, that's what's going to tell you the pH. Okay, similarly here with the pOH, if you look at the exponent, that's what's going to tell you the pOH. Okay, so for example here, the concentration is 1 times 10 to the minus 9 molar. Remember, molarity is how we measure concentration. So if you look at the 9, that's the exponent, that's going to be your pH. Is it that easy? Yes, it is. Okay, so basically, if your pH is 9, and then the pH plus the pOH is 14, then you know your pOH is going to be 5, because 9 plus 5 is 14. So this equation that I've just highlighted, pH plus pOH equals 14, basically that means if you have the pH, you can easily calculate the pOH, and if you have the pOH, then you can easily calculate the pH. So like always, really the best way to see this in action is to do some examples. And these are the examples in your notes packet. Here I have hydrogen concentration. Okay, so they're telling me my hydrogen concentration is 1 times 10 to the minus 9. So I'm going to look at this exponent, and that's a 9. So that's my pH. Okay, now recall that pH plus pOH is 14. Okay, so that would make my pOH 5. Now, to determine if something's an acid or a base, you have to look at the pH, okay? If the pH is above 7, then it's a base, okay? If the pH were below 7, then it'd be an acid, okay? For the next one, they gave us the hydroxide concentration, okay, guys? The pOH is going to come from your hydroxide concentration. So because your hydroxide concentration is 1 times 10 to the minus 5, that exponent is going to be your pOH. Remember, this and this are related, okay? So because your pOH is 5, that's going to make your pH 9 again, okay? So this is also going to be a base. All right, the reason I'm showing you this is just so that you could see, okay, one goes for the hydrogen concentration and one goes for the hydroxide concentration. Okay, the next one is giving us the hydroxide concentration. So that's going to give me my pOH. Okay, notice the exponent is 6. So my pOH is 6. And since it has to equal 14, that's going to make my pH 8. Now, because my pH is 8, that's above 7, this is also a base. Okay, the next one gives us my hydrogen concentration. That's going to give me my pH. Since the exponent is 3, my pH is going to be 3. Okay, so 3 plus 11 is 14. Now, to determine if it's an acid or a base, we have to look at the pH only. So because the pH is less than 7, that's going to make it an acid. Okay, now what's different is we have actual compounds. Okay, so HCl here, that's an acid. If it begins with a hydrogen, Okay, the hydrogen is in front. Oh, that's bad English here. If it begins with a hydrogen, then it's an acid. Okay, and if it ends with hydroxide, that is a base. Okay, so this is our way of noting whether something is an acid or a base. Okay, so obviously here HCl is hydrochloric acid. Okay, well, if I put the negative log of this into my calculator, that's going to give me my pH. Okay, and then from there I can calculate my pOH. Okay, so that's going to be my pH. So that is 0.85, okay, which makes the pOH 13.15. Because the pH is less than 7, that's an acid. For the next one, that's lithium hydroxide. So lithium hydroxide is a base. Okay, so I'm going to do the negative log of 2.56 times 10 to the minus 2. And that's going to give me my pOH because, again, this is a base. So I'm going to find the pOH first. And that's going to be 1.6. Therefore, my pH is 12.4, which makes sense because lithium hydroxide is a base, so it should have a pH above 7. Okay, the last one is cesium hydroxide. Okay, so it's a hydroxide, therefore it's a base. Okay, if it's a base, you have to find the pOH first and then calculate the pH. So here's my concentration. The pOH is going to be the negative log of the concentration, which is 5.1 times 10 to the minus 3. Okay, and that's going to be 2.3. And then 14 minus 2.3 is 11.7. And because the pH is above 7, that's going to make it a base. Okay, so I know that some of you don't have a calculator at home, but I did want to show you this logarithmic relationship. Basically, if it's an acid, you just plug in the concentration, you do the negative log of the concentration, that gets you your pH. Okay, but if it's a base, you want to find the pOH first. You do the negative log of the concentration, and that gets you that number for the pOH. From there, you can just calculate the pH with this equation. pH plus pOH is equal to 14. Okay, remember, if the pH is less than 7, it's an acid. And if the pH is above 7, it's a base. Okay, really, I want you to know what we did on the previous slide, where you just look at the exponent and then you can determine what the pH or the pOH is. But this is just an extension for those of you who like a little bit more of a challenge. Okay, I hope this helps, and I'll see you next time.